Question 18. A heating element in an appliance is designed to consume a power of 1.5 kilowatts. The element has a resistance of 8.0 kilo ohms. What is the current flowing through the heating element? This question tests our understanding of electrical power and how power, current, and resistance are related in electrical circuits. So, what do we already know? We know that electric power is the rate at which energy is converted or transferred. It is measured in watts and sometimes expressed in kilowatts for larger values. We also know that power, resistance, and current are related through one of the standard electrical power equations. In particular, power can be written as current squared multiplied by resistance. This relationship tells us that for a given resistance, the power consumed increases with the square of the current. Now let's work through the solution step by step. First, we write down the quantities given in the problem. The power consumed by the heating element is 1.50 kilowatts, and the resistance of the element is 8.0 kilo ohms. Before substituting these values into the equation, we must convert them into standard SI units. 1 kilowatt equals 1,000 watts, so 1.50 kilowatts becomes 1.50 times 10 to the power of 3 watts. Similarly, 1 kilo ohm equals 1,000 ohms, so 8.0 kilo ohms becomes 8.0 times 10 to the power of 3 ohms. Now we select the appropriate power equation. Since we are given power and resistance, and we need to find the current, the most convenient relation to use is the equation power equals current squared multiplied by resistance. Next, we rearrange this equation to make current the subject. Dividing both sides by the resistance gives current squared equals power divided by resistance. Taking the square root of both sides then gives current equals the square root of power divided by resistance. Now we substitute the values into this expression. The current equals the square root of 1.50 times 10 to the power of 3, divided by 8.0 times 10 to the power of 3. This is approximately 0.433 amperes. So, the current flowing through the heating element is about 0.433 amperes. This is our final answer. What did we do? First, we identified that the quantities given were power and resistance, and we needed to find the current. Then, we converted the values from kilowatts and kilo ohms into standard SI units of watts and ohms. Next, we used the electrical power relation, power equals current squared multiplied by resistance, and rearranged it to make current the subject. Finally, we substituted the numerical values and evaluated the square root to obtain the current. To summarize the key ideas from this problem, when the voltage is not given, the equation power equals current squared times resistance is often the most direct way to relate power, current, and resistance. Finally, always convert quantities such as kilowatts to watts and kilo ohms to ohms before substituting into equations. Since unit conversion errors are a very common source of incorrect answers,